Well, hello scrappers, and welcome back to my channel. And I bet a lot of you immediately recognize what these are right here. Yes, I've got a bucket full of, well, not quite full, but a bucket of the bottoms of gold corner BGAs right here. I've got a lot of them. They've been accumulating for a while as I process my BGA chips. So, I have tried in the past to get the gold out of these, and I have not yet found a really economical way to do it. Because there's not a lot of gold here, but it takes a fair amount of effort to get it. So, like I say, not really economical. There's some gold, but it's almost not worth going after unless you've got a fair number of them like I do. So I'm going to try something new today, something I haven't tried before. It's an experiment. It may or may not work. You know, it may be spectacular. It may be a spectacular failure. I don't know. We'll find out together, I guess. So what I'm going to do is I'm going to process these just like I would process the tops, basically, and see what we get. So since this is an experiment, and you know, the Mythbusters have a saying, the difference between science and just screwing around is writing it down. So we're gonna get a little data here along the way, and just see what kind of a yield we can calculate on this. So the first step on that, I guess, is going to be weighing them up. So let's see. And one went flying. Throw it in all the way down, we'll move the scale. Okay, so we got, let's see if I can zoom in on that for you. I don't know if it's showing up or not. I can't see on the viewfinder. 2 pounds, 2.4 ounces, or, oh, I need to replace this scale. The mode button doesn't seem to want to work. 970 grams. Okay, so that's how many of these we've got. Or that's how much we've got in weight anyway. Okay, so like I said, I want to process these just like I process any other kind of IC chip. So that means I'm going to incinerate them in my foundry furnace first thing. So I'm going to pack them in this crucible and put them in the furnace. But first I'm going to put this air line in the crucible down to the very bottom, and that's going to conduct a stream of air down to the bottom of the crucible, so that everything at the bottom gets to oxidize as well as the stuff at the top. And I'll have a nice oxidizing flame in there. We'll get this stuff all heated up, and it can burn off all the organics, and it can oxidize the tin. I'm going to have to do this in at least two batches because my crucible's not big enough to hold them all. And we'll see what happens. This could be a waste of time. I don't know. But it's a lazy Saturday morning. Nothing better to do. See if I can get a little gold out of these. Okay. That's enough for now. I'll put this stuff in the foundry furnace and we'll get it lit up. Okay, there's the stuff loaded into the foundry furnace. Give you a look at the setup overall here. So there's the foundry furnace, there's the lid to it, there's the burner, there's the propane tank that supplies the burner, there's an air regulator here that's going to supply just a trickle of air to this air hose that's going down to the bottom of the crucible, and my air compressor is out of frame to the left, and it's going to supply air for this. So what I'm going to do is I'm going to start the burner, get everything good and hot. I'm going to put the lid on the foundry furnace. I'm going to put a stack on the top of it. Although it's awful windy, it may just blow the stack right off. We may run without the stack today. That'll probably mean it's going to be a little smokier than usual because the stack's really good for reburning the smoke. But going to get it started, and then once it looks like everything's up to temperature, really good and hot, the crucible's glowing bright, I'll start a trickle of air going from the regulator through there, and I'll start turning down the fire, turning down the propane fire, And eventually I'll have the propane fire off, and just the trickle of air will keep going in to oxidize any carbon that's produced, because when you heat up organic stuff like this, you wind up pyrolyzing it, basically turning it into carbon. But I don't want carbon, because carbon traps gold. So the trickle of air going in will burn the carbon from the bottom, while the atmospheric air from the top will burn it down from the top, and what we'll wind up with is nice, well oxidized stuff. No carbon, which is a beautiful thing. And the number one question I get whenever I do this, because I got lots of other videos where I'm doing this with IC chips, I'll put a link to one or two of them up here. Number one question I get is, what air pressure are you using? And to be perfectly honest, I have no freaking idea what pressure I'm using, because my regulator, the gauge on it's broken. But it doesn't matter. It's not about pressure. It's just about a little trickle of air. I don't want too much air that's gonna whip the fire up into something so hot that it's going to melt all the metals together into one big blob in the bottom of the crucible, which will happen, because basically after this stuff's pyrolyzed, it turns into charcoal. And if you blow enough air on a hot charcoal fire, it's going to get super hot. It'll get up to 2,000, 3,000, 4,000 degrees, and it will melt all that metal down into one little blob. So I just want a little trickle of air, just enough to slowly oxidize all the carbon without whipping it up into a massive flame. And it's more a matter of experience, just sort of looking at it and twiddling the knob a little bit and just say, okay, that looks like we got a little bit of a low fire going on down in there, and that's good. So, sorry I couldn't answer that question with more numbers, but you know, it's just sort of an experience thing. You got to try it and figure it out. All right, let me get this lit and get this show on the road. So again, we're starting out with the air turned off. And I'm going to try putting the stack on. I don't have high hopes that it will stay there with this wind, but we'll see. Okay, we're lit, burning, lid on, stack on. And now it's just a matter of letting this stuff get good and hot. It's going to heat up real quick, and because you know there's not a lot of mass there. Oh, here comes the smoke already. But what will happen is, if the stack stays on, it has little teeth cut into the bottom of it down there. Let me zoom in on it a little bit. And what those teeth do is they allow air to come in from the bottom. And once the temperature gets up above a certain point, the flue gases will start reburning inside the stack, and the smoke level will go way, way down. So hopefully we'll get a good clean burn if the wind doesn't blow the stack off. Oh yeah, things have gotten warm. Got the fire tornado effect going on. There's a lot of reburning going on in the stack. The smoke levels come way down, and things are cooking right along. I'll be starting to turn down the propane soon and turn up the air. Alright, well, we've gotten to the point where I've turned the fire way down and I've got the air going just a little bit. I think we're pretty much there. If I go look at it, there's almost no flame left. Everything's glowing orange in there. I think I can probably kill the propane and turn the air up a little bit, and then just leave it until it cools down, and we'll see what we got. So the propane is off. Turn the air up a little bit. Yep, that looks pretty good. We got a flame coming out of the crucible. The smoke increases a little bit once I turn the propane off, but that'll die down quick. And that was actually really fast. A full load of IC chips, which is going to be a lot more mass than those BGA backs, would take a lot longer to burn off. This actually only took a few minutes, so we'll just let it sit there, oxidize all the carbon in the crucible, and slowly cool down until I can handle it, pull it out, and we'll get the second load in. I don't know if it's showing up on the camera or not. I can't see the viewfinder out here in the sun, but there's sort of a faint glow down in the crucible, kind of like, you know, the coals in your barbecue grill when they're good and hot and you're ready to put the burgers on. That's the kind of glow we got coming out of there right now. That's exactly what I want to see. Right amount of air is going down in there. It's oxidizing away any organic material, any carbon. And once that glow fades away and things cool down, I can pull that crucible out, get the stuff out of it, reload it, and do another run. Altogether, I'd say it's probably been 25-30 minutes, so this is going pretty quick so far. Okay, it's been a while. I went in and had some lunch, come back out, and this is probably cool enough for me to get out of there with gloves now. The volume has dramatically reduced. I see some melting, which I was a little worried about because they are fiberglass, and although the fire probably wasn't hot enough to melt the metals, it may have melted the glass in the fiberglass mat. So it may be a stuck together mess. We'll see. Let me get the camera up on the tripod, get the crucible out of there, and we'll take a look at it. Okay, let's see what we can do with this. The crucible's still a little warm. I mean, hey, it was glowing bright orange less than 2 hours ago, so still a little warm. The airline broke. There's a piece of it still in there. That's normal. After 4 or 5 firings, the airline gets so brittle it just falls apart. I consider it a consumable item. I buy the brake line in big rolls. Yeah, this is kind of, it's coming out though. That's good. Break it up a little bit. There's another piece of the airline. Got crystals on it. Thinking that might be, that's weird. I don't know if that's showing up on the video. Let me see. Some weird crystals growing on the side of it. Might just be glass. I don't know. Yeah, I was kind of afraid that the glass in the fiberglass might consolidate on me. Not as bad as I was worried it might be. Some big chunks at the bottom now. I'm hoping it's just glass. I don't know. It's kind of got a metallic sheen to it. You know what? There is some metal there. I might have overheated this a little bit, and the metal might have melted a little bit too. That's some copper there. That's definitely melted. I don't know if that's showing up. Okay. So, my process is designed around running a crucible full of plastic IC chips. And as they outgas and pyrolyze, they steal a lot of heat from the fire. But these things, they don't have near as much mass, they don't have near as much organic material in them. So I'm thinking I probably need to run a little cooler for the second batch. Speaking of the second batch, I don't know if I'll get that today because the weather, there's some weather rolling in. We might get some rain here shortly. And I'm probably going to have to chip some of the stuff. It's probably not showing up because it's dark down in there. Probably going to have to chip some of that stuff out of the bottom of the crucible and get it in here. Like I said, this is an experiment. Now on the bright side, these things crumble really nice. So I'm hoping I can just run them through my blender like I do with IC chips and bust them up. Yeah, and get rid of the light stuff and just keep all the metal. The metal is what's plated with gold. Hopefully there's some silver in here too, although I don't know for sure yet. So, alright. Partial success. I got a little too hot. A little bit of it melted. I got to chisel it out of here. And we'll see about on the next group if I don't get it quite so hot, how it turns out. We'll have to try running it through the blender. mashing it up nice, and then do a gravity separation on it just to keep the metal and get rid of all the ashy, glassy stuff. And then we'll treat the metal with nitric acid, and what's left behind ought to be gold. And hopefully, if there's silver here, the silver will go into solution and we can get that back later too. So if the weather holds, I will do a second load. Otherwise, it may be tomorrow when we continue this. Alright, the dark clouds that looked like they were going to dump rain on me any second have passed. We got a window of sunlight, so I've started the second batch going. The first batch went pretty quick, so if there's more rain behind what just came through, I should be able to get this done pretty quick. I'm not going to run this as hot or as long as the first batch, and try not to melt down as much of the metal this time, so I don't have to chip it out of the bottom of the crucible. We'll see how it goes. Alright, well, we're waiting on the second batch to get done, and I just turned off the fire on them. I didn't run them as hot or as long this time, so we'll see what we get. I'm running a little less air too at the end, so it doesn't stoke the fire up too hot. But while I'm waiting on that to cool down so I can deal with them, I'm going to start processing the first batch. And look how much the volume has been reduced. That's amazing. And sorry about the droning of the fume hood in the background. I've got another experiment going on in there that may become the subject of another video if it's successful. We'll see. Always trying new stuff. So what I'm going to do is I'm going to put some of this in here. I'm going to put some water in. And we're going to, will it blend? That's the question, will it blend? Well, it'll blend if it's plugged in. Probably not otherwise. There you go. What do you know? My poor, long-suffering Hamilton Beach blender still works. Probably had 100 pounds of chips or more go through it. See what we've got here. Oh, look at that. That looks like mostly copper. Hope that's showing up. That looks like mostly copper. But some of it is way too shiny, like it's gold plated. Nice. Nice. Okay. Get it off my fingers here. What I'm going to do is I'm going to put this back in the blender. And I'm going to put probably the rest of them in here, I think, because this is not a huge batch. So my object of doing this is to get rid of the ashy stuff, the little bits of fiberglass left, whatnot. So what I'm going to do is, once I get this all sifted through the sieve, what will go through the sieve, I'll set the stuff that won't go through the sieve aside. I'll do gravity separation on what does go through to get rid of all the lightweight ashy stuff, and then I'll combine what's left with the stuff that wouldn't go through the sieve, and then we'll treat it all together. Because the stuff that won't go through the sieve is pretty much metal, and the stuff that'll be left after the gravity separation in here, it's metal. And I want to treat the metal. Get the gold out of it. Speed this up. Yeah, lots more metal. Got a lot of metal here. And I could tell some of it is probably aluminum. Some of those chips probably had some aluminum in them. So we'll see. I may have to treat this with some hydrochloric acid just to get rid of the aluminum. We'll see. But I think what I'm going to do, because there's still a lot of other stuff in here that isn't metal, I think I'm just going to run this through the blender one more time. At least one more time. And see if I can separate out any more of the ash and whatnot from it. Just get as close to just the metal as I can. I just had a terrible thought, and I think it's probably more likely than my aluminum theory. Let me look at this stuff again. Stuff out of the bottom over here. Stick in the blender. That's better. These big lumps of shiny metal, they might be tin. Those might be from all the tin balls on them, on the bottom of those BGAs. Might be what that is. Maybe not aluminum after all. It's pretty dense. I'm thinking denser than aluminum. So that's a possibility, and not a good one either, because tin and gold just do not get along. Wow, there's a lot of them in there too. Well, I might have to think about that a little bit. Again, a bath in hydrochloric acid would probably get rid of them. Probably dissolve a little bit of the copper and some of the other stuff in here too. So either way, aluminum, tin, whatever, a bath in hydrochloric acid is probably not a bad idea. Boy, that one's really shiny. Maybe it's just beat up by the beaters in there. I don't think it's silver. I'm pretty sure it's tin and or aluminum. But I do see some nice gold-plated copper in here. You know, another possibility, rather than trying to dissolve this stuff in acid, I suppose, would be treating it with the Eco Goldex gold plating stripper. That might be another possibility. And I wouldn't have to worry so much about the tin in there. Well, let me set aside this first batch and think about it while we're waiting on the second batch. Okay, I've been giving this some thought. I'm almost certain this stuff's tin. And my idea of using the Eco Goldex, I think I will do that in the future when I have BGA backs to deal with, because we'll never be able to calculate our yield this way if I use it this time, because I'll have to mix up, you know, a fair amount of it, a liter, half a liter anyway, and there's probably not very much gold in here. It will strip that gold plating off in seconds probably, and then I'll have to run a bunch of other gold plated material through it to use up the rest of its stripping capacity. We'll never be able to figure out how much of that gold came from this stuff. So I guess I'm going to go with my original plan, which was to treat this stuff with acids. I will probably have to give it a boil in hydrochloric acid to get rid of all that tin, and that may take a day or two. But on the bright side, some of the copper will dissolve too, I'm sure. And that'll mean I'll have to use less nitric acid to dissolve it later. So, because nitric acid is a lot more expensive than hydrochloric acid, so that's fine. The weather's coming in again. It's looking like it's imminent storm. So I'm probably going to start cleaning up out here, putting things away. Probably won't get around to dealing with the second batch till tomorrow. The foundry furnace is still pretty hot. So I will probably just cover it with something and leave it till tomorrow just so the rain doesn't get in it. And we'll pick up tomorrow. See you then. Okay, it's the next day. I got the second batch out of the foundry furnace, and we'll sort through that in a second. This is the oversized stuff that wouldn't go through the sieve yesterday. So I've been thinking about this overnight. Yeah, Eco Gold X would definitely be the right way to go. But like I said, we'd never be able to calculate a yield. So what I think I'm going to do is I'll just sort through this stuff and I'll pick out the biggest. I'll just sort through this stuff and I'll pick out the big balls of tin and set those aside. And the rest of this I'll give a hydrochloric acid boil to and see if we can get rid of the little bits of tin out of it. I probably should have treated these things with hydrochloric acid before incineration to get rid of the tin. I was hoping it would oxidize it in the furnace into a powder, but it doesn't look like that happened. It looks like a lot of it ran down and made balls in the bottom. So, okay. So anyway, I got this in here. So what I'm going to do is I'm going to do the same process that I did before. And we got some stuff stuck to the tube again. Same process I did before. I'm going to grind these up in the blender. I'm going to have to get something to scrape the stuff out of there. Grind these up in the blender. Oversized stuff can go in here. And we still got the undersized stuff down here to deal with. I'll show you that when it happens. So let me get the blender back out and deal with this stuff. And then we'll move on to other things. Alrighty, just like before. Put a generous handful of this stuff in the blender. Definitely didn't get it as hot as last time. The copper didn't melt in places like in the first batch, so that's good. But the tin still all melted and ran down to the bottom of the crucible, made big balls. So that's still a problem. Yeah, probably should have pre-treated those BGA bottoms with some hydrochloric acid, giving them a boil in hydrochloric acid. That would have dissolved the tin fairly quickly off of them, and I wouldn't have to be dealing with it right now. So this is an experiment, you know. We're learning as we go along what to do, what not to do. Okay. Of course, it's still yet to be determined whether any of this is even worth the effort. We'll find out. I don't know if the color of this is showing up on the video. It's you know, I know it's mostly copper, but it's showing up like a brassy color because a lot of that copper is gold plated, which is nice. Very nice. Very nice indeed. That actually looks like a pretty good grind. I don't think that needs to go in again. And not seeing a whole lot of big tin balls in this one. They may have all sunk to the bottom. I pried a couple of huge chunks of tin out of the bottom of the crucible. So most of it may have sunk to the bottom. May not have so much to deal with this round. But there may be some in the bottom of this bowl. We'll see. So that worked really well. Yeah, the rest of this in here. Maybe not all of it. Not right away. A little water in there. That is some good looking stuff right there. Now that's looking like I could go straight to nitric acid on that and dissolve away the copper and just leave the gold. What I might do is I might segregate this from yesterday's stuff with all the tin balls in it. You know, it might be easier just to pick out the gold-plated copper out of this than to pick all the tin balls out. That's what I think I might do, actually, is spread this out on a flat surface, pull out the copper-plated, or pull out the gold-plated copper pieces out of that and leave the tin balls behind, because there's a lot more tin balls than anything else in there. So this is some good-looking stuff, though. I like this. This look like it's pretty much 100% thin copper, gold-plated. That's nice. That's really nice. The last of it in here. There's probably some tin balls in the bottom of this I'll have to pick out. Oh yeah. Oh, there's a big one. Right there. You hear that hit the bench? Yeah, so there's some... Yeah, that's easier. I'm just going to pick copper out. Copper's gold-plated. Shows up really easy. Leave all the nasty tin balls behind. Okay. Whoops. Wash out the blender here. Good. Oh yeah. Okay, yeah, there's some tin balls down there that came through on that last batch. But what I'll do is I'll just pick out all this fluffy copper stuff and put it in a beaker, and we'll process it, and we'll leave all that nasty tin behind. Okay, and what I'm going to do is I'll go do a gravity separation on what's down here in the bottom of this bowl. There may not really be much down here we want to keep. I'm sure there'll be some little flakes of copper that made it through the sieve, and that copper will be gold plated. But I don't know. It may be mostly just crap down there. We'll see. I guess we'll find out together. So this is all garbage. I'll dump that out, dump that in there, and sort through it. And I'll sort through that, and we'll just get the fluffy gold-plated copper out and leave behind everything else. Let me get set up for a gravity separation. I'll show you that. Okay, I don't know if there's actually anything in this undersized stuff worth keeping, but we'll give it a little gravity separation and check it out anyway. You know, I've become much more conservative, you know, after a few years of doing this, and hesitant to just throw stuff away that doesn't look like it has any value to it, because, you know, what was it Crap Games said in Kelly's Heroes? You know, you never know, there might be a bonus. And yeah, there might be a bonus in this stuff somewhere. Hey, if nothing else, there's going to be enough little balls of tin here to keep me in stannous chloride solution for the rest of my life. But we'll see what else is down in the bottom of this bucket. Get it agitated really good and pour off the lightweight ashy stuff here and see what stays behind. Now there should not be any gold pins, or there should not be any gold bond wires here. The bond wires should have stayed with the epoxy blob tops of the BGAs. But again, you know, we're going to be conservative, and we're going to check it out and see. It looks like there's anything of value in here. Certainly seems to be a fair amount of heavy stuff. It's black and it's heavy and it's staying behind. Not sure what that would be. I do see copper in it. There's lots of little bits of copper in it. So if there's copper in it, that copper is probably gold plated. Because it looks like most of the copper in these BGA bottoms was gold plated. Okay. Agitate it really good. Pour off the lightweight stuff. Oh yeah, I see gold plated copper in there. Okay, it's starting to show through now. The gold really jumps out at you. Okay. Yeah, I guess we're going to have to keep this stuff. There was a bonus. I don't know what the bulk of the black stuff is, but it's pretty heavy. I don't know where it could have come from. Hope there's not a lot of tin in it. But there is a fair amount of gold-plated copper in here. I can see it. Wash off a little bit more of this lightweight stuff. Okay, I guess we'll just keep this stuff and probably treat it with acids too and see if we can get any gold out of it. I will probably mix it in with the fluffy stuff because I don't think there's probably enough in here to bother treating it by itself. I suppose I could get my gold pans out and pan it down to where it's mostly just the copper. We'll see. I might do that. Alright. That's the gravity separation. Okay, just for funsies, I did get out my little mini cleanup pan here, and I've been panning into this this bowl here some of the stuff from the gravity separation. I'll tell you what, I'll try to get a picture of it. There is a lot of gold-plated copper in here, but the problem is there's not much of a density difference between that thin gold-plated copper foil and whatever this other black stuff is. So I don't feel like I can efficiently pan it out to concentrate it. Maybe if I had the sluice out and I tuned it really carefully, I might be able to concentrate it a lot and get rid of a lot of the black stuff, but there's not enough material here to bother with setting up the sluice. So what I will do is I'll just put this back in here, put what I panned out in the bottom of this bowl back in here, and we'll run all this stuff with the fluffy copper stuff that came off the blender, just to get all that gold plating in there. Don't want to lose it. So, yeah, that's what we'll do. I don't think I can pan this stuff efficiently. There's just not enough density difference. I would like to know what that black stuff is. I don't know. I hope it's not mostly tin. But I'm going to give this stuff a boil in hydrochloric acid before doing anything else with it. That will digest any tin that's in there. So, won't have to deal with that later, hopefully. Okay, moving on. Gold mining tools have so many different uses. I got my my gold panning sieves out, and I ran yesterday's stuff through it, and I don't know if it's showing up, but see all the balls of tin in there, the big balls of tin. But a lot of the little stuff fell through, and it makes it a lot easier just to pick out the wads of gold-plated copper foils, separate them from the tin. And what I will probably do is, after I get all this stuff separated, I will probably run this through the next smallest screen and separate the stuff out again. And do that as long as it's practical. Once I get down to below a certain size, I think I'll just put it all in here and just let the acids attack it. I'll have to give it a soak in, or a boil probably, in hydrochloric acid to digest the bulk of the tin. If I hit it with nitric acid straight off, we'll make metastatic acid. The infamous gray goo, we don't want that. We certainly don't want that. That is a disaster always. So, I'll, that sounded like a piece of tin. I don't know what that was actually. So we don't want that. We don't want metastatic acid. So I'll give it a boil in hydrochloric first, and then that should digest all the tin. Give it a few rinses, and then we'll hit it with the nitric acid and dissolve away the copper, and should just leave behind nice pretty gold foils. We'll see if it works out that way. I've got to find a less tedious way to do this. So next time, definitely, when I've got a bunch of these BGA bottoms to process, I will hit them with the hydrochloric acid up front and take off the tin balls so that I don't have to worry about doing this later. Okay, after lots of incredibly tedious sorting, I have the vast bulk of the gold-plated copper foils in this beaker here. Now, I've had plenty of time while sorting, because this was painfully tedious and slow. Plenty of time while sorting to think about things. I know I didn't get all of the gold-plated copper foils out of this. This is mostly tin here. This is a very heavy bag. This is mostly tin. And I was thinking about this stuff, which came out of the gravity separation. Yes, I can see copper in there, but that black stuff is dense enough that I suspect most of it is probably tin. So I'm thinking what I'm going to do, just to make my life somewhat less miserable here, is I'm just going to deal with this stuff right here. And we'll just put an asterisk beside whatever yield number I get out of this, because I wouldn't be surprised if 5% or more of the gold-plated copper is in these two things right here. But it's going to be incredibly difficult to get out. I'm going to have to dissolve all that tin away first. And I'm sure some tin has made it over into this. You know, none of the big balls, but I'm sure a lot of little balls and bits of tin are in there. So I'm going to have to dissolve those away. So this is going to be a little unconventional. First thing I'm going to do with this is I'm going to give it a hydrochloric acid boil to dissolve the tin. Some of the copper will dissolve too. That's a bonus. Then what I will do is, to get rid of the tin, because tin and gold just do not get along, get rid of the tin. After the hydrochloric acid boil, I'll pour off the liquid and I'll rinse this a few times with distilled water. Then we'll get it into nitric acid to dissolve the whatever copper's left. Then, after the nitric acid's done, we should just have gold foils in here. Then we can go to aqua regia. So it's a little bit of a strange procedure, but I'm hoping it will work. I just hope there's enough gold in here to move the scale that we can actually calculate some sort of yield, and I just haven't been wasting my time. But at least I'm the one wasting my time. You can just watch what I'm doing and say, oh, well, that wasn't worth it. Don't emulate it. So, okay, so let me make some room in the fume hood and we'll get started on this. Okay, I've got our fluffy gold-plated copper foils in here. Ignore this. This is another project I'm working on. Just extracting some gold from IC chips. I've got like 80 pounds of IC chips to process, so there are always some going in the background. And that's probably not going to be enough acid to do the job, so let me open up another jug. Oh, I got to get over to Ace and get the better acid. I don't like this nasty yellow stuff. The nearest Ace is such a long drive away. Alright, that's probably good. 600 milliliters, we'll call that good. Put a little heat to it. Put a lid on it. Now we'll just let that boil for a while. I even let it boil for the rest of the day and even into tomorrow to try and get rid of as much of the tin as I can. Tin is just terrible stuff when you're trying to do gold. When you're trying to do gold recovery and gold refining, tin is just the worst. It's the same process as what happens with the stannous chloride solution. If there's tin present, it makes the gold come out as a colloidal precipitate when you're trying to precipitate it, and it doesn't want to clump up. It doesn't want to agglomerate together. It comes out as a microfine powder, which is impossible to deal with. So you want to get rid of the tin. You really do. So we'll boil that, see if we can get rid of the tin. Then we'll hit it with the nitric acid, then the aqua regia. Well, it's the next day. It's quite chilly today. First chilly day of autumn, I guess. This was on the boil pretty much all day yesterday, boiling the material in muriatic acid. So I believe we've gotten rid of the tin. I don't see any down in there. And I think after such a long boil in muriatic acid, we should have gotten rid of all the tin. This is probably a good passable stannous chloride solution in here now. There shouldn't be much left in here except our copper foils, our gold-plated copper foils, and a little bit of debris. So what I'm going to do is I'm going to give this a few rinses. Oh, we got some crystals growing. Some kind of crystals growing on the copper foils. That's interesting. So I'm going to give it a few rinses. First I'm going to rinse it with tap water, and then a couple of rinses at least with distilled water. I want to try and get the stannous chloride and basically any leftover hydrochloric acid out of here before I hit it with nitric acid, because we're not ready to make aqua regia yet. Let me see, one more tap water rinse. Those crystals, whatever they were, dissolved pretty good, so that's good. We'll be rid of that, whatever it was. Slight blue-green tint to the liquid, so some of the copper went into solution. That's all right. All right, we'll start with the distilled water rinses. Not very much, but you know, a little bit of copper went into solution. I'm too lazy to get my pH papers out, so we'll just give it a couple rinses, call it good enough, put it back in the fume hood, hit it with some nitric acid. And all this finely divided thin copper foil, this should be an amazing reaction too. Let me tell you, even though everything's good and cold this morning, when the acid comes in contact with that copper, I'll bet we'll see a heck of a reaction. It'll heat itself up real quick. One more time. One more time and we'll call it good. And I'm hoping there's some silver in here too. Some of that metal in there doesn't really look like copper. I'm hoping it's silver. Silver's always a nice bonus. Okay, calling that good enough. We'll get it back in the fume hood and we'll get some nitric acid on it. Alrighty, here we go. So this is back in the fume hood. Put a little more distilled water on it, just enough to maybe cover all the metal. Yeah, maybe a little more. Let me get the fume hood running. Should have started that up earlier. Okay, here we go with the nitric acid. This should be interesting. Oh yeah. Better not put any more in. I don't want to have a boil over, but that is a very vigorous reaction. And it immediately, I don't know if you saw that, the liquid immediately turned blue. So it'll take probably a couple of additions of nitric acid to dissolve all that metal. And then we'll see what we got. I'll do a test on it and see if there's any silver in solution too after we get the metal dissolved. And then we'll see what gold's left. Should be interesting. We're on our way. Okay, the reaction's pretty much slowed down to nothing. All the metal might be dissolved after that first addition of acid. I kind of swirled it around, looked at it, can't really tell if there's any copper left in there. I'm just going to give it just a little dab of acid. Not a lot, just a little, just to see what happens. Oh, yeah, that's a pretty vigorous reaction. I'd say there's still some copper in there, so I'll put a little more in. And let it cook a while longer. Make sure we get all that copper dissolved. And then we'll go from there. Oh, we're on about our fourth edition of acid. I'm putting it in really small increments because there's hardly any solids left in that beaker. Just a little bit on the bottom. So almost everything has dissolved. I'm starting to wonder if maybe my hot plate's running hot and the acid's just boiling off real quick when I add it. I don't know. I kind of doubt it because the water's not boiling really. So I don't know what's going on. Hopefully the reactions will stop soon. If I put a little more acid in, I won't get a strong reaction. And hopefully there'll still be something left in the beaker. Hopefully it won't all dissolve away. We shall see. Well, I am kind of at a loss about what's going on in there. I keep adding acid to it. I keep getting a strong reaction. There's very little solids left in the bottom of the beaker. I'm really having a hard time believing that acid is dissolving much of anything. I keep turning the temperature down on the hot plate too. It's not that hot at all, really. I'm thinking well below the boiling point of nitric acid at this point. So I don't know what's going on. Some chemical in there catalyzing the destruction of nitric acid? I don't know. It's weird. Strange stuff happens when you do experiments. If you knew what was going to happen, you wouldn't be experimenting. It would be a procedure. It would be a process. It wouldn't be an experiment. So I don't know what's happening here, so my experiment seems to be going off the rails a little bit. At some point, I'm going to call it and stop adding acid to it because, like I said, there's not much solid left in the beaker. and the amount of solid that's there doesn't seem to be getting any smaller. So I don't see the point in continuing to add acid just to have it boil off or whatever's happening to it here. So, see, I've got a process. This other beaker over here, see, there's nothing happening in that beaker. That's got a bunch of IC chip remains in it. And it behaved exactly as I expected. You know, I boiled it in nitric acid, it took 2-3 additions of acid, and then the reaction stopped. You know, just like I was expecting. This reaction doesn't seem to ever want to stop. So, like I said, at some point I'll call it, and we'll move on to other things. Probably decanting off the liquid and then hitting it with some aqua regia, just to see what happens. Strangeness. Okay, this reaction has been going on literally all day. It's starting to get dark. This is ridiculous. I'm not putting any more nitric acid in there because I'm sure all the copper, any silver that was in there was probably dissolved by the second addition of nitric acid. Whatever's going on in there now, I'm not sure. I have a sneaking suspicion. Maybe I didn't get rid of all the tin. And maybe the tin is reacting. I don't know. I don't really see like metastatic acid forming, but it's possible. I don't know what's going on, but I'm not putting any more nitric acid. I'm going to let this reaction die down, let the liquid settle and clear up, and once it's not so turbid, I'll do a test on it for silver. That may be tomorrow, because like I said, it's getting dark, so I may just let it sit overnight. It'll clear up. We'll do a test for silver on it, and then we'll go from there. Decant off this blue liquid, give it a few rinses, see what's left in the bottom looks like, and then if I think there's still tin in there, I may give it another hydrochloric acid boil before going to aqua regia, rather than just going straight to aqua regia after this. We'll see. It's just not behaving the way I expected it to, so it's a little troubling. So we'll see what it looks like in the morning. Actually, come to think of it, it may have to sit a couple of days, because tomorrow is the day before Thanksgiving, and I'm going to be babysitting the smoker all day because we're smoking a turkey for the family. And then the next day is Thanksgiving, and we're going to relative's house, so yeah, it may be Friday before I get back to this. We'll see. Well, happy Thanksgiving, everyone. We've got a few hours before we have to leave to go join the family for Thanksgiving dinner, so I thought I'd mess around with this a bit. Had all day yesterday to think about it, because we smoked a turkey, we cooked pumpkin bread muffins, all our cooking's done, it's all ready to go. So, yesterday I was thinking about this. First off though, look at that color. Isn't that amazing? That is an amazing blue color. I don't quite understand why that is such a deep dark blue. But there's lots of stuff I don't understand about what's going on in here. But I was thinking about it because it looks like maybe we have created some metastatic acid down here, some of the infamous gray goo. But the question is, where did the tin come from? Because I gave this stuff an all day long boil in muriatic acid. And that should have digested all the tin in there. But I had a thought. What if those bronzy colored foils that I thought were gold-plated copper, what if they actually were bronze? And what's the recipe for bronze? Copper plus tin. So maybe as soon as I put the nitric acid to it, we started digesting bronze instead of copper, like I was thinking. So that's a possibility. That could be where some tin could have been still hiding in there, and how I've got some metastatic acid in there. Not a lot, but it sure looks like there's a layer of it on the bottom of the beaker. And somebody in the comments on one of my recent videos asked me, what is your recommendation for dealing with metastatic acid? And well, to quote everyone's favorite Star Trek movie, prayer, Mr. Savick, because metastatic acid does not take prisoners. That's my recommendation. But I think we'll just forge ahead as if it's not even there. I think that's my plan. So what I think I'm going to do is I'm going to decant off this really pretty blue liquid. First we're going to test it to see if there's any silver in it, because some of those foils look kind of silvery. So we'll test it and see if there's any silver in it. Then we'll decant off the liquid and we'll rinse the goo at the bottom. Hopefully there's some gold foils in there. That would be nice. And then we'll hit it with some aqua regia and see if we can dissolve some gold. Then we'll do a stannous chloride test to see if we're getting any gold. And there's not so much metastannic acid in there that I'm worried about it completely smothering the gold. I think with some agitation, I think we can get the aqua regia in contact with any gold foils that are in there. So let me get set up for a test to see if we got any silver in this pretty blue liquid, and then we'll go on from there. Okay, let's test for silver. So I've got a little bit of tap water in this beaker. Let me get some of this pretty blue fluid out of here. We'll put it in here. Squish it around a little bit, and if there's any silver in there, it's too little to worry about, because that is pretty darn clear. Maybe very slightly cloudy, very, very slightly cloudy. If there was any significant amount of silver in this stuff, there'd be this would be really cloudy right now with silver chloride. So I guess there was no silver there, at least not any significant amount. So we don't have to worry about this liquid. This is probably mostly copper nitrate solution, but there may be something else in there because it is awfully, awfully blue. Copper nitrate solution isn't usually this blue, even when very concentrated. So there must be traces of some other blue salt in there. Not sure what. I'm going to decant off this liquid, get rid of it. I'll give the solids in the bottom of the beaker a few rinses with distilled water, and we'll hit it with some aqua regia. Okay, interesting and good news. First, the good news. The metastannic acid actually was pretty easy to deal with. I swished the contents of the beaker around really hard. The metastannic acid stayed in suspension in the liquid, and I was able to decant it off. I did that a few times, gave it some distilled water rinses, decanted it off, and pretty much all the metastannic acid left with the rinse water. So that's great. And then I could see, finally, get a good look at what's going on in the bottom of the beaker, because there was a layer of metastannic acid on it. There's a lot of copper left in this beaker. So it's back on the heat. It's getting another nitric acid boil, and as you can see, there's a fairly vigorous reaction going on by all these fumes. So, okay, I think the metastannic acid was masking all the copper left on the bottom of the beaker. I couldn't see it. I couldn't understand why I was still getting a reaction every time I added some more nitric acid, but it wasn't really some vigorous reaction like this. It was kind of muted. I think because the little bits of copper were just buried under the metastannic acid layer, and they weren't getting good contact with the acid. So now we've got a really good vigorous reaction going. Hopefully I can get the rest of the copper in this beaker digested, and then we can move on to aqua regia. So it may take a couple more boils in nitric acid, but we'll get there eventually. I mean, I got nothing better to do. I mean, I may be wasting my time on this, but you know, it keeps me from getting too bored while I'm working on this, which is just bog standard processing of IC chips, which I do practically every day because I've got a ton of them, a literal ton of them I need to process. So, you know, nothing new about that. Same procedure every day, nothing changes. It's a little boring, so I throw these experiments in just to keep myself amused and interested. So we'll see if anything comes of it, though. It might just be a waste of time, but at least it's keeping me from getting bored. Alright, it's been a couple hours and I've put a couple small additions of nitric acid in here since that first one where I got all that reaction, and there's nothing really happening. I think we're finally done, and I just did a test on this for silver and see how cloudy the liquid is. Now I'm going to take that with a grain of salt because it's possible it made some more metastatic acid and that might be suspended in the liquid, and that's what's caused it to be cloudy rather than silver. But I will decant this off into a beaker that I'm keeping liquid that has silver in it into. So I'm going to let that accumulate, and then when I've got a fair amount of it, a few liters, I will try and cement silver out of it. But I'm not going to bother with this little bit of liquid right here, try to get the silver out of it for this test. I'm just hoping there's some gold down in there somewhere. So what I'll do is I'll decant this liquid off, give the increasingly small amount of stuff in the bottom of the beaker a rinse or two with distilled water, and then we'll go to Aqua Regia and see if we can actually find some gold. Okay, I've decanted off the blue liquid, given it a few rinses with distilled water, and really, to keep the movie quotes going, I've got a bad feeling about this. I don't see any visible gold in there. You know, I've switched it around like I did before. It allowed me to see the copper. Copper's all gone. That's a good thing, I guess, but I don't see any gold. I guess the way to know for sure is to hit it with some Aqua Regia and then do a stannous chloride test, huh? So that's what we will do. We'll make some Aqua Regia, we'll let it cook a little while, and then we'll do a stannous chloride test on it and see if there's indeed any gold in there. Where could the gold have gone if it's not in here? That's a good question. Oh, that's got to be more than enough nitric acid, seeing as there's no visible gold in there. So we'll just let that cook for a bit and do a stannous chloride test on it. See if we get any kind of reaction out of it too as it warms up. That should be interesting. If all the metal's really gone, there shouldn't be any kind of reaction. What am I seeing? There might be a slight reaction starting. Hard to say. Let it warm up. Well, it's been a few minutes. The Aqua Regia has warmed up a bit. There's something going on in there. We'll just let this go and then do a stannous chloride test. Maybe there's some superfine gold in there going into solution. Hey, hope springs eternal. Okay, I hope that is showing up on camera. That is like the world's weakest indication of gold in solution. That is barely purple. Barely purple. And that is the liquid in the fume hood. In there. Been boiling in Aqua Regia for a while. I got busy with other things. The weather went to crap, so it's been sitting here for a while. And there's very little gold in there, obviously. I mean, that is so weak. That is. I actually show it better from this angle. That is such a weak indication of gold. And I get a lot of crap in the comments about using the white spoon method instead of just a little slip of filter paper. So I'll tell you what, the white background of the spoon really shows off weak indications like that. I doubt I would have been able to see that on filter paper, but I could see that on the spoon. So there is some gold in here. There's definitely a little bit of gold in here, but certainly not very much at all. Certainly not worth all the effort I put into this, but you know, it was just something to keep me from getting bored while I was working on this. So, I'll have to sit down and have a discussion about where to go from here. Well, that wasn't very productive. I've tried 3 different ways now to get the gold out of these things. 3 different ways. And in the end, I wind up with the same thing each time. Just a trace of gold. Not even worth the effort. So let's see, what other ways have I tried? I've tried boiling these in muriatic acid and then in aqua regia. And same thing, just trace gold. I've tried putting these through the Eco Gold X Gold Stripper. And weirdly, a lot of the gold just doesn't come off of them. I'll soak them in the gold stripper for a long time, and you know, maybe the little golden corner will come off. Maybe it will, maybe it won't. But a lot of this stuff in the middle doesn't come off. Don't know. Maybe it's got some sort of coating on it. Maybe it's got a layer of resin on it from the fiberglass or from the epoxy blob that was on there. I don't know. And then, you know, I've just tried this incineration and acid treatments, and same thing, just a trace of gold. I don't think there's enough gold in these to make it worthwhile, really. And I thought, you know, starting with as much as I had this time, I'd get a decent amount of gold. But no. Still only getting a trace. So, yeah, I've come to the conclusion that these really just aren't worth the effort. This is why, you know, you go on YouTube and you see lots of people who have videos on processing the tops, the blobs. And then they'll say, oh, part 2 will come along where I'm going to do the bottoms. And then part 2 never arrives because they try and they try and they try and they can't get any gold out of them. Well, I got a little bit of gold. I think I'm just going to dump this right in my stock pot, the contents of this beaker, rather than try and precipitate the gold out of it. Let the gold precipitate in the stock pot, and I'll get it back out that way. Because there'll be nothing but a very light dusting on the bottom of the beaker if I try to precipitate out this weak liquid here. So, yeah, anyway, I think I'm just going to stop messing with these. And I would recommend the rest of you, don't bother. They're just not worth the effort. You know, heck, the tin on them's probably worth more than the gold. So, maybe I'll melt down all those little tin balls I've got and make ingots out of those. I don't know. But I think I'm done playing with these. And I would recommend the rest of you don't waste your time either. They're junk. Alright, well, that was an interesting experiment. You know, hey, even a poor result is a result. Okay? Remember that. So, anyway, thanks for watching. I hope you found this video a little bit interesting, educational, helpful. Give it a thumbs up, give it a like, and subscribe to see future videos, and press that little bell icon that YouTube makes you press to be notified when new videos come out. And thanks again for watching. See you around.